Okay, nursing and paramedic students, today we're going to go over the Parkland formula and the rule of nines. This is how we kind of initially treat a burn patient. Rule of nines will help us determine the percentage of body surface area that a patient has burned. And we're going to look at partial and total thickness burns for these patients to calculate the percent of body surface area burned. So once we know how much body surface area is burned, we can plug that into the Parkland formula, which will tell us how much fluid that they will require in the first 24 hours. And then I'll show you how we break it down, how much fluid we give them the first 8 hours and the following 16. So the first thing that we're going to look at is the rule of nines. That is just a quick, easy way to determine how much body surface area has been burned. So pardon my artistic ability here as I draw a little human here. So the rule of nines, basically we want to come up to 100, because 100% that's everything on the body. And I guess I should include the hands here. So we know everything is going to want to equal 100%. So in the rule of nines, we know we need 11 nines. That's going to equal 99%, and then we just have one more percent to go. And the 1% will be the peri area. So the rule of nines is pretty simple. The head is 9. So the whole head, front and back, that's 9. So if you just burnt the front, that would be 4.5. Each arm is 9. And that is circumferential. So the whole arm, the whole circle away around the arm. Then the chest is 9. The abdomen is 9. So let's say we're looking at this from the front. And then we'll draw a little guy here on the back. This is going to be the back. Remember, the head is 9, so be 4.5, 4.5, but just 9 total. So the back will be 9 upper back, 9 lower back. The legs are the same. So the legs are a little different than the arms in that it's 9 for the front and then 9 for the back. So each leg is a total of 18. So if we add this up, we know we have a 9 in the arm, a 9 on the chest, a 9 on the abdomen, a 9 on the other left or the other arm, 9 for the head, 9 for the leg front, 9 for the other leg front. So that gets us 1, 2, 3, 4, 5, 6, 7. So we know 9's 9. So the back, this would be the 8th 9. This would be the 9th 9, the 10th 9, and the 11th 9. So that's how we get all of our 99% and then the 1% for the peri area. So the main thing to remember is the arms are 9. The legs will be 9 front, 9 back. So there will be a total of 18 for each leg. Each arm is 9 only. 18 for the front trunk. 18 for the back trunk. And then 9 for the total head. So this will help you determine how much of the body surface area is burned. So remember, we need to come up with 11 nines. So we have 2 for each leg, that's 4. 1 for each arm, that's 6. 2 for the front of the trunk, 2 for the back of the trunk, so 6 plus 2 plus 2 equals 10. And then our 11th 9 is the head. So that's 99, 1 for the peri area. There we have it. I'm going to erase this real quick, and now we'll go into the Parkland formula. Okay, so now we're going to look at our Parkland formula. And this is how we're going to calculate how much fluids we're going to give them. So it's a pretty simple formula. We like to use LR. Depending on some of the textbooks that you read, some may say NS. For the purpose of this, we're going to use LR. So we want to use 4 milliliters, and we're going to call it LR. We're going to multiply that by total body surface area affected or burned, or body surface area, times the patient's weight in kilograms. So we're going to do a little example here we're going to say this patient, you came out on a scene for the EMS students, and let's say they fell into a vat of hot water. So everything below the waist is burned. So real quickly, we know from our rule of nines that we have a 9 for the front of the leg, 9 for the back of the leg. So each leg is going to be equal to 18%. So we have 2 legs, so we know 18 times 2 is equal to 36. And it came from the waist down, so we know we got the peri area, so we'll add 137. So I'm going to have to do some math on this one. So we're going to say he's a 100-kilogram man. So we know he's 100 kilogram, and we know that he's burned 37% of his body. So we know then we can just do our math here. 100 times 37 is going to be 3,700. Multiply this times 4. I'm going to have to do this in my head real quick. 12,000, 14,800 milliliters. That's how much fluid we're going to need to give him, and then this is in the first 24 hours. So that's a lot of fluid. As you can see, these burn patients take a lot of fluid because they're going to be third spacing like crazy, these fluids. So this Parkland formula, we want to give the first half of the fluids in 8 hours, in the first 8 hours. The second half we're going to give over the next 16 hours. So basically we're going to want to divide this 14,800 by 2. That's going to give us, so we're going to want to give 7,400 mils in the first 8 hours. So if we divide that by 8, that's going to be how many mils per hour we're going to want to give. So that's basically going to be about 9, wow, that worked out. 925. Double check my math at home on that. So that's going to be equal to 925 mils per hour for the first 8 hours. So you can see that's going to be a lot of fluids. We're really going to be giving that fluid. Then the easy way to calculate how much you're going to need for the next 16 hours is if we give the first half in 8 hours, we're going to give the same amount but only over 16 hours, so we're going to give it twice as long, so we can just divide that by 2, and then that's going to be equal to 462.5 mils per hour. And that's how we're going to give that. I'm going to clean this up and then I'll kind of show you again the formula. Okay, we're going to look at that formula again here real quick. Remember, it's 4 milliliters multiplied by total body surface area burned multiplied by patient's pound or kilograms, weight in kilograms. And then once we determine that, we're going to give 1/2 of that fluid in the first 8 hours. And we're going to want to give 1/2 in the next 16 hours. So basically, whatever you give in the first hour, you're going to divide it by 2, and that's what your rate will be for the following 16 hours. So first 8, we're going to give a lot of fluid because the fluid's going to be shifting quite frequently. They're going to need a lot of fluid up front, and then we're going to give the rest of it over the last 16 hours. But remember, we're going to want to watch our urine output real closely. So our urine output with these burn patients, we're going to want it to be 1/2 milliliter per kilogram per hour, and that's going to be a good way that we can tell if we have the patient adequately hydrated. Thank you very much. Hopefully this helps.